All right, with our functions, how many of you guys would say that functions, which includes what? Compositions, mostly compositions. How many of you guys would say this is one of your weaknesses? Oh, wow, surprising. This is almost always a weakness. Are there any clarifications that we needed on functions, specifically compositions? How do you read when you have, for instance, F and then some sort of notation, a bracket or a parenthesis, and then G? What is this? F of, not F times, right? So you're always plugging in. There's a lot of examples as to plugging in, but no other further clarifications? We're good? Okay, intercepts. How many of you guys say intercepts are a weakness? Main thing, intercepts, we just need to memorize which one's which, right? We just need to memorize which one's which in the sense of x-intercepts at y equal to 0, y-intercepts at x equal to 0. Sometimes there's some fun algebra, but otherwise no big deal. AJ. Oh, yeah, go ahead. Yeah. How'd you get what? Oh, distribution. 2 times 25 is 50 minus 1. And it was a positive, right? Yeah. And then the 25 made sense from the foiling? Okay. Yeah. That distribution. You might have killed a seal. Okay. Back to intercepts. Anything further clarification on intercepts? Okay. Points of intersection. What's the long story short of points of intersection? Like, what's the solving tip? Yeah, but you're just setting them equal to each other, right? You're finding some way to set them equivalent to each other. So it could be like in this one, the easiest way would have been to solve both for y and then set equal. Points of intersection, we're trying to get the two equations together. That way we can solve for what they have in common. So yeah, there were things like possibly doing elimination or substitution, solving the system. There are different ways of solving the system. But in essence, we're setting the two equal to each other and then going from there. Domain and range. Okay, let me alleviate some fears. The biggest thing I want you for the quiz tomorrow to be able to do is domain, not range. Range is hard because you need to visualize the graph and think how low to how high. Domain is a lot easier because you might want to do colored pen. Quick note about domain. Aren't there some domain problems, what to look out for? It's in your pre-cal notes, but I can also remind you here. So, some domain things to think towards, or domain problems to look out for. First of all, don't we need to look out for fractions and denominators? Right? So denominators can't equal 0. So if you have a denominator, set that not equal to 0 and solve. Maybe including some factoring. Domain, what if you have a radical expression? You can set your radicand greater than or equal to 0. Number 3, you can set your logarithmic argument greater than 0. Those are the main ones. You're not going to have to worry tomorrow about like vertical asymptotes that show up in trig functions. We'll get there. But for right now, what if I was to do something like find the domain of, let's have fun with it. How about 3 over the square root of x plus 1? What do you guys think? How do we find the domain? Okay, because radicand, that's talking about a radical. So yeah, we have a radical. So Patricia's like, take the inside. That's the x plus 1 part. Take the inside, take the x plus 1 part. And then she said greater than or equal to 0, which is almost all the way perfect. She's right. She's solving. She's doing -1, but she's forgotten one thing. Yeah, you can move the -1 to the other side. That's totally right. But this is actually still wrong.
No, I mean, it can be 1 or...
It cannot equal 0. Why? You had both problems. So not only did you have a radical, but you also had a denominator. So therefore, we would actually not set it greater than or equal to 0. We have to say greater than or equal to 0, not what's greater than or equal to, but not equal to? Just greater than. Interval notation. Was that in your packet at all? It was, right? Interval notation would have been starting, if it's greater than -1, it starts at -1 and goes to, do you guys remember how to end an interval? Bracket if it's or equal to, but it's not or equal to, so parenthesis. So starting at -1 greater than is going to where? Infinity. Why is there never a bracket on infinity? We can never get there. That's just another way of writing it, though. I would take either one on the quiz tomorrow, the greater than or the interval notation. The log argument, what I was talking about with that is if we had, we could have this be example 1 and this be example 2. Log argument, if I had something like ln of x plus 3 for domain, we would take the log argument and set it greater than or 0. And as you guys notice up here, like there is some solving in the sense of getting x alone, right? But so if there's a log, we follow this trick. If there's a radical, we do follow greater than or equal to, unless it's also denominator can't be 0. If it's just denominator, just don't say, or just say not equal to 0 and solve. But anyway, domain problems. You're not going to have to worry about range. We're going to have to grow into that a little bit more this year to become super proficient masters at it. But domain is the one thing I want you to take away from this section. You're not going to have to worry about using graphs for domain or range. It's just going to be using functions and seeing things like, oh no, radical, set it greater than or equal to 0. Yay, greater than or equal to 0, or -3 to infinity. Oh no, denominator, set it not equal to 0. Oh, x can equal 1. That's what you have to worry about for tomorrow. Inverses, long story short, take x and y and switch and solve for y. Anybody say inverses are a weakness? I didn't ask about domain range. Some of you, that was yours. Who doesn't like domain range? Okay, like 1/3. Inverses, any clarification needed? Yeah, Michael. Okay, hold on. The switching makes sense, right? Okay. And then we had to get to the y. The dilemma is, though, we can't touch this square root, because remember the y is trapped. It's like a little composition of functions until we subtract the 1. So hence why we subtracted the 1 first, because the square root ends on the x. It doesn't keep going. So subtract the 1. Then square root just needs a squared on both sides. Then we just have to finagle a little bit. I subtracted the 4 and multiplied by a -1. You could have also added the y and subtracted the x minus 1 squared. Either way, you end up here. And then we can say inverse. So getting rid of the 1, squaring both sides. Then to get rid of this, it kind of depends on your brain. Some people, like in my brain, it's easier to add the y and just have it be positive, so be y plus and then subtract. Some people, it's easier to subtract the 4, which I did here, and then multiply by a -1. But does that kind of make sense, the step-by-step? Good. Any other clarification? Okay, remember, be real, let me know. But you're right, there were like online math labs, and there was the answer key. I get it. Just making sure I'm not forgetting anyone or not forgetting, leaving someone behind. Equations of lines. It's very possible this will be on the quiz tomorrow, in some way, shape, or form. My advice for equations of lines, if I were you, is just to know the most important form of an equation of a line in calculus. What version is this? Point slope. What do you need to plug in? Say the name again. Point. Yeah, you just need a point. You just need slope, right? So you can, for the point, you can just pick any point. They can give you 1, they can give you 2, they can give you a dozen, but you just need one of them. You get to choose. Just some point on the line goes in this spot, the x1 and the y1. The y stays fixed and the x stays fixed. So we're just trying to plug in a y1 and an x1 and an m. M, could they give it to you? Yeah. Could they not? Yeah. What do you do if they give you 2 points and don't give you a slope? Good. You have to find it. Rise over run. Change in y over change in x. Right? What if they say something nasty like, well, they don't give you 2 points, and instead they say something like parallel to. What do they mean if it's parallel to something? Keep the same m. So somehow you might need to rearrange it. Figure out the m of whatever they give and then use the same m in that spot. What if they say, what else can they say? Perpendicular to. Do you guys know the little sign for perpendicular? Perpendicular to? AJ, you were saying it. What do you do with m? Careful. Opposite and reciprocal. Opposite sign and flip it. Opposite reciprocal m. So you take whatever, figure out what the m is of whatever they've given you. Flip it. If it's 4, it's 1/4. If it's 2/5, it's 5/2. Flip it and make it opposite sign. That's it, I think. Any clarifications needed on those questions, though? Some of you guys, lines not so hot, you don't like them, you get tricked by them easily? Okay. You can have more than one weakness, by the way. Just vote for all the ones you're like, yeah. Unit circle. Sorry, guys. Have it memorized. I don't know what to tell you. Have it memorized. We'll talk more about it, and I'll rag on you a little bit more about it, too, if you don't have it memorized. But some of you are like, I can memorize. I got that. Other things are hard. Some of you are like, I'm lazy, or memorizing is really hard, or both. It could be one. It could be the other. You just have to memorize. Let's just go straight to trig equations. I don't want to have you guys stressing over trig equations because they are kind of nasty if you don't need to. It's important for this year. It's totally important for this year. But is it important for the quiz? Oh, you don't want to take that quiz. That's BC. It is not. Did you hear me? It is not important for the quiz. Sound good? Okay, so is this a hard page? Totally. Could I go over clarifications? Totally. Is it unit circle backwards? Totally. Not on the quiz. Sound good? Now, what did I not say that about? Know it. Okay. For any of you that are new to me this year, I was really hard on them last year about it, so that's why I'm giving them a hard time. This page, it's good. It's really good. For tomorrow, it's good. Vertical asymptotes and horizontal asymptotes. How many of you guys, the asymptotes get confusing? Okay. Can I just do a quick recap? Is that all right? Okay, short and sweet. We have VA, vertical asymptotes, and we have HA. Similar in the sense of vertical asymptotes coming from left or right, you're getting closer and closer and closer, but never touching. Horizontal asymptotes, as you're going to the right, to the left, the y's are stabilizing closer and closer and closer, but never touching. So one way the x's are stabilizing, one way the y's are stabilizing. Nothing in that for you to memorize for tomorrow. Instead, the solving is what's important. Vertical asymptotes, we look to factors, let me make it easier, zeros of denominators that can't factor, reduce away. Vertical asymptotes. We look to the denominator. If there's no denominator, perfect. There's no vertical asymptote. Look to the denominator. Find the zeros, aka factor it, set those factors equal to 0. Find the zeros of the denominator, DNE, that don't factor and reduce away. So a quick example, if I was to do something like find the vertical asymptotes of x plus 3 all over x squared minus 5x plus 6. That's not going to make sense. Let's do that. Okay, we're not even talking about limits right now, even though I totally could go into that. Okay, if you're looking for vertical asymptotes, where do you look? Denominator. How do I find zeros of this guy? Yeah, to find the zeros, I'm going to want a factor. So it's going to be easier if I say, okay, hold on, what can that denominator factor to be? All right, x minus 2 and x. I had to change my numerator. Zeros. Oh, cool. X equals 2 and 3. You're right. The domain can't be 2 and can't be 3, but which one is the vertical asymptote? If you want, you can now remember if 2, the one that doesn't factor and reduce away, is the vertical asymptote, what's 3? It's the whole. The one that does factor away as a whole, just a little point discontinuity. The one that doesn't factor away is the vertical asymptote or the infinite discontinuity. So both of these are bad. The domain for both of them, if we were doing domain, x can't equal either one, but 3 is not a vertical asymptote because it factors and reduces away. Horizontal asymptote. Sorry. It is what it is. Degree tests. Horizontal asymptotes. Degree tests. Degree tests. If the top wins, we'll get there. If the bottom wins. Remember, we're thinking about degrees, magnitudes of the numerators and denominators. Wait, there is no fraction. Well, then it doesn't have a horizontal asymptote. You can only have horizontal vertical asymptotes of rational functions or fractions. Top wins, bottom wins, tie. Top wins, I don't know, something like x squared plus 2 all over x minus 1. Top wins. Is it held back? Is it limited? Will it have a horizontal asymptote? The answer is no. Why? Because if we were taking the limit as x goes to infinity, end of the packet, the numerator is going to expand faster than the denominator. The whole thing is going to an infinity. It's not leveling off. No horizontal asymptote. If the bottom wins, something like, we could just flip it. All of a sudden, the horizontal asymptotes are going to be held back to 0. I could change these numbers. I could change the degrees. As long as the bottom degree is stronger, always, 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 horizontal asymptote, aka limit as x goes to infinity, will always be 0. Degree tests not only find horizontal asymptotes, but also limits to infinity. Sorry, I'm saying that out loud and I haven't written it anywhere. Hadn't written it anywhere. Tie. X plus 3 all over 4x minus 1. Ratio of the leading coefficients. Leading coefficients. Who are the guys who are determining the magnitudes? Those ones. Horizontal asymptote at y equals y, because there's an understood 1 in front of any variable on its own. VA, look at the denominator. Whatever zeros don't factor and reduce away. Horizontal asymptote, degree tests. Top wins, bottom wins, tie. The answers depends on which case it is. Does that make sense? Clarifications on anything on vertical asymptotes? Yeah, Michael. Yeah. I didn't necessarily say which one, but I said both are really good to look at. So maybe it's not a which one question. Okay, exponential functions and logarithmic ones. Exponential functions and logarithmic ones. Guess what? Also helpful. P.S. I don't think I actually said it. Composition of functions, very helpful as well. If you guys want to go back really quickly, functions. I didn't specifically say it, but I meant to. Composition of functions, very helpful for tomorrow to peek at as well. Now we're down at exponentials and logs. You guys okay if I do a long story short of what will be helpful for tomorrow? Is that cool? Because we're going to see these things over and over again. Not that we're going to need to learn them like we did in pre-cal. We're just going to have to kind of remember things as we go, and I'll be reminding you of algebraic stuff as we go as well. Let's think just in general, exponential and logs. Exponential, remember you have some sort of variable in the exponent. Exponentially, you have some sort of variable in the exponent. Let's say we had something like 3 to the 2x is equal to. Let's say we had something like 3 to the 2x is equal to. And then let's say over here we had something like 1 over 27 to the x. Sure. And we're supposed to solve for x. Logarithmic, what if I was to give you something like simplify? Let's not even do that. Let's do solve log base 2 of 3x plus 1 minus log base 2 of 6 is equal to log base 2 of 12. Okay. I'm just trying to think of like all the different properties you could possibly need. Without using your calculator, without using ln to undo the exponential, what is the key to using that great property that we loved last year called the one-to-one property, where we can just kind of have them disappear? They have to be the same. So the struggle is he's a 3 and he's a 1/27th. Pause. Who's 27? 3 cubed. Might be easier if it was 9, it'd be 3 squared, but 27 is 3 cubed, right? So couldn't I rewrite this as 3 to the 2x it's a 3, but it's in the denominator. How do I rewrite powers in the denominator? Negative. How do I raise a power to a power? Multiply. And what can I do as soon as I have the bases matching? I can one-to-one property, I can get rid of them. I could do log base 3 of both sides, but ultimately I can just go down to using the one-to-one property, the following. And here's the stinky thing. I gave you an impossible problem, so that's no fun. Let's do a plus 1. It's a struggle when I do things quickly. Ooh, don't kill a seal. You'd have to distribute. Okay, now could you solve? Yeah, get the x terms to one side and then solve for x. How do we do the one-to-one property here? Just like I needed a 3 to the over here, I need 1 log base 2 and 1 log base 2. Is there a property that puts these together? I can divide. The quotient property of logarithms. Now what can I do as soon as I make them match? I can one-to-one property, 2 to the power of, but either way I can go straight to the arguments and say, haha, all I care about is u. And then we can multiply both sides by 6, and we could solve for x. Okay, so with exponential and logarithmic, the main idea is how to use the one-to-one property and knowing your logarithmic properties. Does that make sense? How to put together subtraction, addition, how to take multiplication, make it powers, etc. There's only one other thing on the quiz that's not bonus that we haven't talked about today. which is good because we only have like 5 minutes. Let me make sure I finish talking about the quiz before. Ooh, so I didn't say even or odd? Nope. Oh, 2 other things. Did I not say complex fractions? Sorry, complex fractions. Those ones are important. Lo siento. Let's pause for him or on him just a second. Complex fractions. You know what's really cool? I didn't make this worksheet and they used my trick. Did anybody notice it? They totally used my trick of saying, hey, x plus 1 is stuck. Sweet, let's multiply top and bottom by x plus 1. Now, I didn't like how little they showed their work. They should have put little parentheses, and they should have put like little over ones, and they should have taken him and distributed him, so the -7, they just did a lot of work. But that's what CalcChat did, because they got really good at it, whoever made the answer key and was like, I'm not going to show you the work, it's easy. Okay, apologies. But that's why down here and on the online, I forget if it was live session 1, I think it was live session 1, I went through and showed the work of doing a complex fraction. So if you didn't watch live session 1, and you don't like complex fractions, that's a great place to go look tonight, okay? Don't watch the whole thing. I mean, unless you want to, I suppose. But you can go find the complex fraction-y one that I did, because I worked it out. But I was doing my trick the entire time. If you want to do it the other way, where you get like common denominators of numerators and denominators and put it all together and multiply by the reciprocal, come after school. Let's grab a whiteboard, and I'll show you how. Let's not do it right now. Complex fractions, good for tomorrow. Last but not least, limits. There might be a derivative bonus, but the last regular credit on the quiz is limits. Okay, when you're solving limits, if it's a basic one, like back here at the very beginning, if it's a basic one, if I were just to give you something like this, what's the very first thing you always try in solving a limit? Just try to plug it in, plug it in. We loved those last year. Those were our favorite end of the year problems. Plug it in, plug it in. The limit is 9. Plug it in, plug it in. But what happens when we start having these ones where we plug in and we get 0 over 0? What do we always do when we get 0 over 0? How do we keep going? Well, we can go to these examples right down here. How do we keep going? We can go to these examples right down here. If there's a root, we're going to have to multiply by what we call the conjugate. If it's a plug-in, well, forget it. It wasn't a 0 over 0. No problem. You're done. But if you plug in and it's polynomial 0 over 0, then you factor and reduce. Then plug in. You're always trying to get to where you can plug in and it will work. But sometimes you have to do some manipulation. Sometimes just plugging in, sometimes conjugates, sometimes factoring and simplifying. I don't think it got too much crazier than that, because the next section was horizontal asymptotes, degree tests. Those are the limits to infinity. So as far as limits for tomorrow, it's not using a graph. It's not using a graph. It's using just what you saw right here, as far as if you can just plug in and solve, and you're done. Plug in whatever x is approaching. If it's a 0 over 0, keep going, either with conjugates or with factoring and canceling, then plug in and it'll work out. Were there any huge questions on limits as far as how to solve them? Okay, so guess what? This was all part 1 of the summer packet, but you guys had a whole second part. I just said that the second part is not on the quiz tomorrow, except there will be a bonus that has to do with finding a derivative with a rule. Probably power or product. The other 2 we'll save until we get to them in calculus. You guys have a good idea what's on the quiz? Okay, summer packet. Have it as fully attempted as possible. I might actually not have you turn it in until Thursday. That way tonight you can just focus on the quiz. And if there's something else you needed to ask me, we'll do it either tomorrow after the quiz or Thursday first thing. Sound good? All right, cool. Get out of here. Bye, guys. I'll be here after school if you need me.
Oh, we gotta go. Oh, we gotta go. We gotta go. We gotta go.
Oh, is it AP Gov?
Yeah, AP Gov.
Yeah.
Most of them are good, but there's some pages.
There's some weird things, right? Okay, you just left those separate?
Yeah.
Thank you.
Oh, I kept you late.
So you don't
Yeah.
want this in paper, did you? I just signed it just in case.
No, the online form's good unless you wanted to add a prayer request. You can give it to me anytime.
All right.
Is that cool? Thanks, Ryan. You too.